Is VCO6 times stable? VCO6 times VCO6 times. Okay, is this stable? Is this a stable carbonate? That is a question that comes to mind to every student who learn organometallic chemistry. There are some reasons for this doubt, because the atomic number of vanadium's atomic number is 23. That is an odd atomic number. Since it has odd atomic number, we don't expect that to form a mononuclear complex. Generally, the complexes with generally the metals with odd atomic number, they generally give mononuclear complexes, mononuclear carbonates. For example, if you are looking into the examples of the mononuclear carbonyls, we have CrCO6 times, FeCO5 times, and NiCO4 times in the first row, right? CrCO, CrCO 6 times, then FeCO5 times, FeCO5 times, and NiCO4 times, NiCO4 times in the first row, because these have the even atomic number. Okay, chromium is 24, iron is 26, and nickel is 28. Okay, so these have even atomic number, these metals have even atomic number, and they form the mononuclear complex. The metals with odd atomic number are expected to form dinuclear complexes. Okay, so vanadium CO6 times is an exception to this rule. So vanadium, instead of forming V2CO12 times, instead of forming V2CO12 times, it is forming VCO6 times. It only forms VCO6 times. What's the reason behind that? Okay, if you are counting the electrons of VCO6 times, we can count the electron. Vanadium has atomic number of 23, so it has a configuration of 4s2 3d3, so it has the valence electrons, 5 valence electrons, right? Chromium has 5 valence electrons. Valence electrons in chromium is equal to 5. And how many electrons are contributed by carbonyl ligands? And 6 into 2 from CO, that is equal to 10 electrons. 10 electrons are contributed, no, sorry, 12 electrons are contributed by 12 electrons are contributed by carbonyl ligands, and totally there are 12 plus 5, that is equal to 17 electrons. So if we are counting the valence electrons of the VCO6 times, there are only 17 valence electrons, and it does not obey 18 electron rule. Okay, so this complex doesn't have the magic number of 18 for its stability. That is one thing. That is one thing why we are skeptical about the stability of VCO6 times. Secondly, it, as we already said, it violates the general observation that only metals with even atomic number give mononuclear complexes. So if it does not have the 18 electrons, what is the next way in front of VCO6 times to form 6 times to get the octet? So not octet, 18 electrons. In order to get the 18 electrons, it has to form this one. Okay, it has to form VV bond. Then each vanadium has 6 carbonyl ligands in it. 2, 3, 4, 5, 6, and this also has 1, 2, 3, 4, 5, 6. Then if you suppose that each of these vanadium is connected with the carbonyl ligands like this: CO, 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 and CO. Okay, now you can count the valence electrons. If you are taking one of the vanadium has valence electrons of 5, then one electron is contributed by the metal-metal bond. Okay, so metal-metal bond is contributing 1, and 6 COs are contributing 12, and then 12 plus 1 plus 5, that is equal to 18. So if it is forming this V2CO 12 times, it can satisfy the 18 electron rule for its stability. Then why it is not actually forming? Okay, the reason is that the if it is forming the vanadium bond, then you count the coordination number of vanadium. Okay, how many? What is the coordination number of vanadium is there in this molecule? Vanadium has a coordination number of 7. 1, 2, 3, 4, 5, 6, 7. So it gets a higher coordination number. Okay, coordination number is equal to 7 in this case. So the problem is that here the ligand repulsion, okay, there will be very high ligand repulsion, and this ligand repulsion will not allow vanadium to take a coordination number of 7. And in other words, ligand repulsion overcome a weak formation of the metal-metal bond. So ഈ വനേഡിയത്തിന് ചുറ്റും 7 കോർഡിനേഷൻ സൈറ്റുകൾ 7 ഉണ്ടായി കഴിഞ്ഞാൽ, അല്ലെങ്കിൽ കോർഡിനേഷൻ നമ്പർ 7 വന്നു കഴിഞ്ഞാൽ സംഭവിക്കുന്നത് എന്താണെന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ, ഇവിടുത്തെ ലിഗാൻഡ് റിപ്പൾഷൻ വളരെ കൂടുതലായതുകൊണ്ട് ഈ വനേഡിയം ബോണ്ടിനെ ഫോം ചെയ്യാനൊക്കത്തില്ല. ഫോം ചെയ്യുകയാണെങ്കിൽ ഒരു വീക്ക് വനേഡിയം ബോണ്ടായിരിക്കും ഫോം ചെയ്യുന്നത്, പക്ഷേ ഇവിടുത്തെ ലിഗാൻഡ് റിപ്പൾഷൻ അതിനെ ഓവർകം ചെയ്യും. ഓക്കെ, അപ്പം so the reason why the vanadium is not forming V2CO12 times is because the ligand repulsion overcome the weak metal bond. Ligand repulsion, let me write it here. Ligand repulsion overcome the weak metal bond formation. Okay, that is why it is not giving the polynuclear carbonyl complex. Okay. However, we have to understand certain facts about that. It is less stable than other mononuclear carbonates obeying 18 electron rule. We already saw some mononuclear carbonyls, and these are the mononuclear carbonyls: CrCO6 times, FeCO5 times, NiCO4 times. And compared to these mononuclear carbonyls, VCO6 time is less stable. Okay, and it decomposes at 70 degrees Celsius. So it's very important to note to decompose at 70 degrees Celsius. Okay, and not only that, if given opportunity, it readily accepts an electron. For example, if VCO6 times is reacted with the sodium, okay, VCO6 times is reacted with the sodium ആയിട്ട് റിയാക്ട് ചെയ്ത് കഴിഞ്ഞാൽ ഈ സോഡിയം എന്ത് ചെയ്യും, ഒരു ഇലക്ട്രോൺ വനേഡിയത്തിന് കൊടുക്കും. ഓക്കെ, so the electron transfer will occur, and then it will form Na plus VCO 6 times മൈനസ്. അപ്പം ഈ VCO6 times മൈനസിൻ്റെ പ്രത്യേകത എന്താണ്? ഈ VCO6 times മൈനസിന് 18 ഇലക്ട്രോൺസ് ഉണ്ട് അല്ലേ? 18 ഇലക്ട്രോൺസ് ആണ് ഇവിടെ വനേഡിയത്തിൻ്റെ 5, then കാർബൺ മോണോക്സൈഡിൻ്റെ 12, then one charge is there, then 1. So total there are 18 electrons. So this will satisfy the 18 electron rule. So whenever getting a chance of given the opportunity, then it readily accepts an electron. Okay, and then it will form VCO 6 times minus. So these are the important facts that you have to understand about VCO 6 times. So it is a stable compound. It's a stable compound which doesn't obey the 18 electron rule, and it does not give the V2COs 12 times. This is because of the ligand repulsion. Okay, too much steric hindrance and to form a 180 bond. And if it is given opportunity, it can readily accept an electron and form VCO 6 times minus. Okay, so these are some of the facts that I have to share with you about 180 CO 6 times. Thank you for watching.